today's problem from mathematical expectation of one-dimensional random variable. And the problem is, if capital X is uniformly distributed over the interval 0 to pi by 2, compute the expectation of the function sinX. Okay, and also find the distribution of sinX. Show that mean of the distribution is same as the above expectation. Okay, so the problem have 2 or 3 parts, and to solve this problem we first use, here it is given that uniform distribution over this. So here we write what is uniform or rectangular distribution. If X is distributed uniformly in the interval AB, then the PDF is given by Fx. This is equal to 1 by B minus A, where A less X less B and 0 elsewhere. This is the definition of uniform distribution. We already write here. Okay, so here we first write, since X is uniformly distributed over 0 pi by 2, so PDF is, here we write the PDF, this is Fx 1 by pi by 2 minus 0 for 0 less x less pi by 2 and 0 elsewhere. Okay, we directly use the result. Now we have to compute the expectation of the function sinX. Now we see what is the definition of expectation. Definition of expectation we already write here. The definition of expectation is expectation phi of x. This is the random variable which is given by integration minus infinity to infinity phi x fx dx, where fx be the PDF. And this expectation is for only for continuous random variable. If it is discrete, then in place of integration we put summation minus infinity to infinity. Also we here see that what is the definition of mean. Mean is given by expectation x, which is denoted by m. Now we here find expectation sinX, and by putting the definition of expectation we write that integration minus infinity to infinity, this is sinX into fx into dx. Okay, now from here fx is 2 by pi in the interval 0 to pi by 2 and otherwise is 0, so the integration becomes integration 0 to pi by 2 sin x into 2 by pi dx. Okay, so we get this is 2 by pi, this is cos x, this is minus, and 0 to pi by 2. So 2 by pi into this is minus cos pi by 2, this is 0, cos 0, this is 1, so we get 2 by pi. So the expected value of sin x, this is 2 by pi. This is our one required result. Now we have to find the distribution of sin x. We first see that what is the distribution or what is the probability distribution. Probability distribution means if a random variable is continuous, then we have to give its spectrum together with its PDF. Or if it discrete, then we have to give its spectrum together with its PML. This is the probability distribution, or simply it's a distribution. So to find the distribution of sin x, we first put y, this is equal to sin x. Okay, now in real variable y, this is equal to sin x. So dy dx, this is given by cos x, and the range of x is given by 0 to pi by 2. So we have to first find the range of y. Since 0 less x less pi by 2, So from here we get the range of y. This is less 1, less 0. This is the range of y. Now how to transfer the variable x to y, since it let that this is y. This is given by this formula. Okay, transformation of random variable. For continuous random variable capital X having PDF of x, if y this is equal to phi of x, here phi of x, this means sin x. This is the phi of x here. Okay, and if phi x is differentiable, clearly sin x is differentiable, and if the same sign for all x, sorry, this is not only phi x, this is phi dash x. Phi dash x. Phi dash x gives the same sign. Here phi dash x means dy dx. This is cos x, and clearly this is greater than 0 for all x belongs to 0 pi value. Then we get the PDF of y as g of y. This is equal to fx into mod dx dy. Okay, so PDF of y is given by gy. This is fx into mod of dx dy. Okay, since it gives constant sign and it differentiable, so we get here fx means 2 by pi and dx dy, this means given by 1 by cos x, and here 0 less y less 1, because this is the PDF of y. Now since this is the function of y, so we must have to transfer x to y. To transfer x to y, we put 2 by pi. This is 1 by root under 1 minus psi square x. This is 2 by pi 1 by root 1 minus y square. This is 0 less y less 1. This is the spectrum and this is PDF. Okay, so this is the probability distribution of y. Now show that mean of this distribution. What is the definition of mean? Mean is given by mean of y is expectation y, and expectation y is equal to integration minus infinity to infinity y gy dy. But here this is 0 to 1 because the range is only 0 to 1 and otherwise is 0. So this is y into 2 by pi 1 by root 1 minus y square dy. Now to integrate this term, we put 1 minus y square. This is equal to z square. So we get minus 2y dy. This is 2z dz. So minus y dy. This is equal to z dz. Right? And the range of integration, by putting here y equal to 0, we write here this is y, this is z. This is y equal to 0 and 1. We put y equal to 0, then z equal to 1, and y equal to 1, z equal to 0. Okay, so we get integration is, this is 1 to 0 and this is 2y dy. So we put here 2 into z dz by, this is 2 by pi is also a constant, and root 1 minus y square, this is z. Okay, and minus is present here because this is minus o dy. So z cancel out, and this is 2 by pi into integration 0 to 1. We change the range of integration and minus together balance them, and this is dz. So the integrand value is 2 by pi into z. This is 0 to 1, so 2 by pi. Okay, so we get mean of the distribution y. This is equal to 2 by pi. This is the second result. Okay, and clearly it is seen that mean of this distribution is equal to expected value of sin x. This is 2 by pi and also this is 2 by pi. So we prove this is the last distribution is the same as the above expectation. This is the last required answer we prove here. Okay, very simple problem of probability. Thank you for watching.